Welcome to Brain Vision.
Okay, so I see that you need help with this question. And so I'm using Excel just to help me organize my data. But you can totally use paper and pencil to answer this. I'm going to explain the process as I go. So if you do not have paper and pencil, if you do not have Excel, what I am using, and I'll show you what formulas I'm doing and such. But if you don't have Excel, totally fine. You can use paper, pencil, and a scientific calculator. So the first thing, in order to find the regression equation, which is what it's asking for, you need to find the mean of x, then the mean of y. So the mean of x, you're going to take up all your values, and x is wavelength. Oops. And so then there is 1, 2, 3, 4, 5, 6, 7. And you're going to take, hold on. You're going to find the average of those values, and you're going to find the average of these values, and I'm going to highlight them and see how I'm assuming that you have some type of Excel program, because doing this by paper pencil would not be fun. So I'm going to round these to 2 decimal places because that's what it wants us to do. So rounding to 2 decimal places. There we go. So then what you're going to do is, let me just bold all this, center it, box it in, and then I'm going to box that in and center everything. Okay, so I'm going to take x minus the mean of x, okay, and then I'm going to do y minus the mean of y. And then I'm going to do x minus the mean of x multiplied by y minus the mean of y. Okay, and let me just make that a little bit bigger. There we go. Okay, so that's what I'm going to do first. So I'm going to take all of these x values and subtract them from the mean of 212.86. And I'm going to drag this down because it will do it for each one of the values, okay? It'll find the difference between each one of these values and the mean. Then I'm going to take each one of my y values, and I'm going to subtract 18.86. Okay, I'm going to drag this down because it will do it for each one of my values. So remember, I'm using this for x and this for y. And bold them and center them. Then I'm going to take this value and multiply it by this value. And then this value times this value times this value, and so on and so forth. Then I'm going to total up this entire column, and this is known as the sum of my products. And okay, then what I'm going to do is I'm going to take each numbers in this column and I'm going to square them. Okay, so I'm going to take this number, square it, and then the next number, square it, and then the next number and square it, and I'm going to total that up. And this is known as the sum of the squares of x. And I'm going to end up using this in here. And I'm just going to bold it and box it off. Okay. So I'm going to end up using these 4 values. So to get my slope, I'm going to take the sum of my products and divide it by the sum of the squares of x. So what that's going to look like, sum of my products and divided by the sum of the squares of x. Oop. Then to get my y-intercept, I'm going to take the mean of y and subtract it from the mean, or the slope, times my mean of x. So what that's going to look like is mean of y minus my slope times my mean of x. And now I'm going to, and I'm just going to highlight all of this, bold it. I like to bold and highlight things. And I'm just going to make this a little bit bigger for you. There we go. And so then what I'm going to do is I'm going to write my A regression equation is going to be y equals 0.04, because it wants you to round to 2 decimal places, x plus 10.56. And then I'm going to merge that and bold. Okay. Then, so that's A. And then for B, using the equation and let's just bold these, and then using the regression equation from part A, estimate the speed in meters per second of a wave that is 200 meters long. So if I do equals 0.04 times 200 plus 10.56. And so the speed of a wave that is 200 meters long is 18.6 meters per second. So I'm going to highlight all of this. So I hope that this video helps you. This is the middle school math teacher signing out.